Welcome back to Algebra 1. We are doing Algebra 1, Chapter 3, Section 7, Formulas and Functions. Now, my background is really biochem. It's my degree. It was not education. I went back later and got certified to teach at Georgia State. And so my degree is in science. And when I taught public school, I actually was a science teacher who got into teaching math because my science students never knew the math they needed to be able to do my science classes. So, and then homeschooled and ended up teaching, pre-K through 12 math and then teaching it to others. So, I actually started teaching math and tutoring math while I was still teaching science in public school. Now, in your book, they approach this, formulas and functions, like mathematicians instead of scientists. And as a scientist, I actually firmly disagree, yes, that's how nerdy I am, with the idea of one of their ideas. Now, what they want to do is they want to take a formula like this. Area equals length times width. You've learned that before, and did you know by tradition these are written in cursive? That's why you had to learn cursive. But length times width, and they want you to solve for length, and what they do is they rearrange the letters before they put in the numbers and solve the equation, and I'm absolutely against it, and this is why. As a scientist, I have memorized hundreds, if not thousands, of formulas. I knew physics formulas, chemistry formulas, math formulas, biology formulas, and if you rearrange this formula, it doesn't stay one formula, it becomes three. You have area equals length times width. You could have length equals area divided by width. You would have width equals area divided by length. Suddenly that one formula is three formulas and you're never going to learn your formulas. And as a scientist, it's really important that you learn formulas. So whenever the book asks you to rearrange a formula for a variable, don't do it. Absolutely not. I never ever want you to do it. I want you to always use a formula the famous way, substitute it in the famous way, then solve for the variable you're looking for. So let's do it here. We have a rectangle whose area is 35 feet, its width is 7 feet. What is the length? We list our knowns and unknowns, we write our formula, we sing the song Substitute. It's by The Who, it's real old. I'm sure I nailed it. Alright, and so right underneath the letter that it goes with, we put the number. So area is 35, so right underneath area we write 35. Length is what we don't know, so I'm going to put X for that. And width is 7. Now, Y is X not alone, it's being multiplied by a 7. We're used to seeing it this way, but it's the same thing that way. So what's the opposite? Divide by 7. So what is 35 divided by 7? It's 5. So the length equals 5. Alright, so that's how I want you to do it. Here's another one. Interest equals your principal, that's how much money you start with, times the rate times the time. Now, in math, we're going to end up learning a lot of different formulas for different ways of making interest. Banks have lots of them, but this is just a simple one, okay? So here's our formula. We start off with $1,500. We earned $54 in interest. Our time was 1 year. What was the rate? We sing substitute and substitute in. So the interest is 54. The principal is 1,500. The rate is what we don't know. And the time is 1 year. But anything times 1 is itself. So I'm just getting rid of that. So we're going to divide both sides by 1,500. Now, this will be a calculator problem. So do 54 divided by 1,500 equals X equals 0.036. And to change something from a decimal to a percent, you move the decimal place 2 places. And how you remember that is the percent sign has 2 zeros. So we move it 2 places this way, 2 frog hops, say ribbit. And so our interest was 3.6, I kind of crowded that, 3.6%. More fun with sound effects. Okay, our next problem is based on this formula. Speed is distance over time. And that's the formula that I told y'all that one time I had some kids and I was trying to get them to remember that formula. I said, how can we remember that? And they said, dead science teacher. I was like, oh, this is going to be harder than I thought. It's fun though. Teaching's fun. All right, so my speed is 30,000 miles per hour. My distance is 310 million miles. This was a spaceship thing. How many days will it take to get there? And we also, notice this is in hours and we're asking days, so we're going to need a conversion factor that 24 hours equals 1 day. So we're going to substitute 30,000 for speed. The distance is 310 million. And our time is our x, what we don't know. So y is x alone is being divided into 310 million, which is making it ugly. So we're going to get rid of the ugly first by multiplying by x by both sides. And ooh, that got rid of that fraction. That's so much nicer. So now we have 30,000x equals 310 million. Y is x alone is being multiplied by 30,000, so the opposite is to divide by 30,000. What you do to one side, you do to the other. We'll do this in our calculator. 310, oops, I gotta clear that out. 310 million, which is 1, 2, 3, 4, 5, 6, divided by 30,000 equals 333.333, and this would be our miles would cancel out, and this would be in hours. But we want to know how many days it is. How you do conversion factors is you draw railroad tracks. Anything in the numerator you multiply, anything in the denominator you divide. You write the unit you want to get rid of in the bottom. We want hours to cancel out. The unit you want in the top. And then you write the numbers that go with them to make them equivalent. 1 day is 24 hours. Multiply, this is equivalent to 1. And multiplying anything by 1 is itself. Because a day and 24 hours is the same thing. And anything divided by itself is 1. If that didn't make sense, that's okay. I just told you mathematically why we're allowed to do it. Alright, so we do 10,333 times 1 divided by 24. And that'd be on our calculator. So I'm just going to hit divided by 24 because it was already up there. And it's 430. Round up, 431 days. Approximately equal. 431 days is how long it's going to take my spaceship to get there at that speed. Now they want you to do that over and over again. We're just doing it once. You can practice and look at the others and make sure they make sense. Now, the other thing they show us how to do is sometimes you have an equation like this and you need to get y all by itself. The reason why is there's a button on your calculator right there that says y equals. And that's what we're going to use to graph lines, but to tell it which line to graph, y has to be by itself. So this time we're going to say to ourselves, why is y not alone? And it's because it's being added to 3x. What's the opposite of adding 3x? Subtracting 3x. What we do to one side, we do to the other. Those cancel out. Can you take 3x from 4? No. To add or subtract, they have to have the same letters with the same exponents. We bring down what we didn't mess with, and by tradition you write x's before bare numbers. So it's negative 3x plus 4 is the answer. Now sometimes your book will write 4 minus 3x, but that's actually bad etiquette. So sometimes they don't follow the etiquette. Scandalous. Alright, so sometimes you have to solve for y, and we'll be doing that more. Alright, that wasn't bad, was it? That was chapter 3. Math is fun. See you later.